Okay, hello everyone, and welcome to today's webinar, Introducing Grantek's CloudEMS, Secure, Compliant, Mobile, and Productive Environmental Monitoring in the Cloud, hosted by Grantek with special guest contribution from our partner in the Platform as a Service space, 4IR Solutions. So, just before we get started, I'd like to offer up a few tips to make sure that everyone gets the most out of our conversation today. First off, I know that it is easy to get distracted, especially because we are all very busy. Some of us are still working from home and some of us are back in the office. Each of those environments brings its own distractions. Phone calls, texts, chats are all hitting us constantly, likely at a mile a minute. So if you can flip your phones over and minimize your email clients, find a quiet space, please do your best to stay focused and engaged as you're able to. Next, take notes. If you find something that we discussed today particularly interesting, jot it down so that you remember it for later. We will be sending out a recording, so you will be able to watch and listen again. But that being said, I know that I like to drop a few notes in my notebook when I watch a webinar so that I know where to go back in the recording later, and I can easily find those sections that were of particular interest to me. Also, if you have any questions that come to your mind as you're watching today, enter them into the chat. Our team will be collecting them for later discussion during the Q&A period after the presentation portion of the webinar. Finally, there will be a poll question that comes up during the webinar to keep things interactive. Please answer as best you can, reflecting your current circumstances as they pertain to today's topic. Okay, let's get to the agenda for today's webinar. So here's a brief list of the topics we're going to discuss today. We'll kick it off with a short introduction where you get a chance to meet your presenters. Then we'll walk things back a bit to talk about environmental monitoring systems and specifically their use in the pharma and life sciences industry. We'll then introduce CloudEMS and talk about the specific value that it could bring to the industry. We'll walk through the application features and focus on how we are handling compliance and cyber resilience concerns. We'll also go through the technical architecture of the solution, which is when I'll hand the reins over to 4IR Solutions. And finally, we'll walk you through our planned roadmap for the CloudEMS solution and where we feel we'll take this product. And then finally, we'll wrap up with a Q&A session. Okay, let's get to it. First up, introductions. My name is Bryon Hayes, and I'm the Director of Smart Manufacturing Solutions at Grantek. I've been with the company for 20 years, and I began my career as a young, fresh-faced engineer straight out of school. My career has grown with the company and has been primarily focused on the life sciences industry, where I've implemented and managed countless automation and information projects. As the SMS director, I manage a portfolio of productized solutions that are focused on the pharma, biopharma, and med devices industries. I also try to stay involved in the industry. I am actively engaged with the International Society of Pharmaceutical Engineers, or ISPE for short, especially in Canada, and I have been involved in their Pharma 4.0 special interest group for about 4 years. James?
Hey, and my name is James Burnand. I'm the CEO of 4IR Solutions. I've been in the industry almost exactly as long as Bryon Hayes. I spent a big chunk of my career working at systems integrators or at a systems integrator for a variety of different end customers. In my past, I've spent many an hour sitting on an upside down bucket at 3 a.m. commissioning systems, doing project management, working in operations and in sales. 4IR Solutions' mission is to blend the best IT and OT technologies together into a platform that makes it easy to adopt and achieve the business value that they promise. And that's what I'm here to talk about today. Thanks for the intro, and pass it back to you, Bryon.
Thanks, James. All right, so now for our first poll question. So the question is, are you using the cloud for GXP purposes today? How many of you haven't even considered using the cloud? How many are planning on it? Maybe some of you are piloting a cloud-based application right now, or maybe you are active cloud users. Okay, go ahead and vote now. All right, starting to see some answers coming in. Looks like a fairly even spread across all 4 categories. We'll give you a couple more minutes. Okay, yeah, it looks like it is a fairly even spread across all 4 categories, a little bit heavily weighted towards the not even considering it or planning on it stages. A few pilot users and a handful of active cloud users as well. So thank you all for your votes. All right. So I know that there are some of you watching this that aren't directly associated with the pharmaceutical industry, and that's great. But to help set the stage for the rest of the webinar, especially for those of you who are not already indoctrinated, I want to include a short intro into environmental monitoring systems, or EMS for short. This information may already be well known or be considered first principles to those already in the industry, but I want to make sure that everyone is on the same page before we move forward. So why might a manufacturer need an EMS? Well, a manufacturer in the pharmaceutical industry must always keep product quality and patient safety at the forefront of everything they do. It's the main reason that the industry is regulated, to protect the public, to make sure that all drug products are safe and that they do what the manufacturer says they're going to do. I'm not going to go into a full lesson of the current good manufacturing practices, but I want to highlight some critical elements that Cloud EMS is designed to help with. Not only are drug manufacturers required to prove that their manufacturing processes are under control and capable of producing quality products consistently to minimize the risk of contamination and cross-contamination, but they're also required to control the conditions under which their products are manufactured and stored. This means things like temperature, humidity, and particulate count within the manufacturing space, or the temperature and humidity of storage areas. So just to highlight that point, I took a few excerpts from the CGMPs as they are defined by the US FDA. This is just a subset of the regulations and the ones that pertain to facility design and warehousing. So to paraphrase, processing operations must be performed under conditions that prevent contamination or mix-ups. There are a number of ways that the FDA suggests this can be done, but I've highlighted 2 of them that are relevant to today's discussion. One is temperature and humidity controls. Another is a system for monitoring the environmental conditions during processing. In addition, warehousing procedures are required to be established and followed. These must include the maintenance of appropriate conditions of temperature and humidity during the storage of the drug product. All of these regulations were put in place to ensure that the identity, strength, quality, and purity of the drug products are not affected by the surrounding environment. That's why drugs are made in clean rooms and warehouses are kept under strict climate control. To monitor environmental phenomena, you could have someone walking around manually recording the information, reading the values from analog gauges or digital displays. That would be time-consuming and would introduce the potential for human error. EMS systems automate this monitoring function, reading data from sensors that capture the environmental conditions and convert them into signals. These signals are then logged and can be trended, displayed in reports, or used in analytic systems. Another function that an EMS typically provides is alarming. If an environmental condition deviates from what is acceptable, the system can trigger an alarm and even notify personnel via communication systems such as email or text message. An EMS supports a manufacturer's requirement for compliance to the GMPs. Okay, so now let's introduce CloudEMS, Grantek's cloud-based environmental monitoring solution. First, we'll talk a little bit about our value proposition and the problems that we are trying to solve for manufacturers in the space. CloudEMS is a modern, compliant, and cyber-resilient platform. It's a secure and robust solution that was created specifically for the life sciences industry. We provide the industry with a solution that leverages the capability of the cloud to safeguard the safety and efficacy of drug products via around-the-clock monitoring of the environmental conditions under which those products are manufactured and stored. Manufacturers get the benefits that the cloud provides, minus the risks, because the product was created using modern IT and software development practices under the auspices of industry guidance around computerized systems such as GAMP. So what problems are we solving specifically for our customers? First is a reduced cost in the efforts to demonstrate quality. We began our process by developing a software quality assurance plan that would ensure that we developed and tested the application in a manner such that we can demonstrate a state of control, which in turn qualifies the application core. We did this using a risk-based approach, leveraging the skill and knowledge of a compliance consultant to identify the system requirements that were of highest risk to data integrity and apply the most rigor to the testing of those features and functions. We did this so that our customers can leverage our activities and evidence rather than undergo extensive qualification, redoing work we've already done. We sought out a past provider that shared these same values and assessed their procedures so we could leverage their activities and documented evidence. We did this so we could trust that our application was built on a solid foundation and would meet the technical requirements for compliance. Next, we provide enhanced data integrity and security for our customers. First and foremost, we utilize modern software development practices along with the associated tools in creating the application. These are threaded into a system development lifecycle to ensure that the application development and testing is performed in a controlled manner. An example is the use of separate environments for development, testing, and production, as well as the ability for developers to check in and out the code for the application features that they're working on. In addition, we ensured that both Grantek and our past provider were following cybersecurity best practices so that our customers' data would be kept secure and protected from malicious actors. Finally, as we are a cloud-based application, we offer one of the primary benefits of the cloud, a reduction in IT infrastructure costs. As you will see when we get into the architecture portion of the presentation, there is a minimal on-site footprint component to CloudEMS. No data center is required. This, in turn, reduces energy and maintenance costs of the system, as these elements are handled by Grantek and our past provider. Okay, so now let's focus in on the main features of the CloudEMS application. We will walk through a few items in this section of the presentation. First, we'll discuss how we enable compliance and maintain cyber resilience. Then we'll walk through the application features and screens. Finally, we'll go over the technical architecture of the system, and this is where I'll pull in James to talk through the PharmaStack PaaS platform. Okay, let's talk compliance. First and foremost, Grantek is no stranger to the requirements of implementing computerized systems in the life sciences industry. We've been around for 40 years and have been executing projects for pharma and biopharma customers throughout that time. We've been audited by many pharma customers, and as a company, we have threaded life sciences compliance requirements into our core policies and procedures. In our QMS and SDLC, we've taken a central tenet of GAMP 5 to heart, adopting a risk-based approach to how we develop our solutions. From specification through to development and testing, we focus on those areas of highest risk to ensure that when we deploy a solution, it will meet the needs of our customers. Throughout the process, we maintain traceability to the user requirements and categorize the risks to determine where the most rigorous controls are needed. Finally, we ensure that our solutions contain the technical controls required to call our systems 21 CFR Part 11 enabled and to support our customers' need for data integrity. In addition, we have put many supporting procedures in place to demonstrate a state of control throughout solution development. These include, not limited to, change management, training, disaster recovery, and periodic review. So to continue this thread, I just want to highlight a point that I made earlier, and that's about our software quality assurance plan. We developed this plan with our compliance consultant such that it takes a pragmatic approach to compliance driven by critical thinking and focusing on risk. So rather than create mountains of documents and sign-offs and retesting elements that our suppliers are providing, we're leveraging their compliance activities. We're also leveraging some of the inherent documentation abilities in the software development tools that we're using, such as the Jira platform. This enables us to demonstrate traceability and control through a centralized tool and build out test plans accordingly. This is in line with the new computer software assurance approach that is supported by the new second edition of ISPE's GAMP 5. We also leverage the agile project philosophy throughout the development of the product, which has gained acceptance in the industry over the past few years, with a caveat. And here's an excerpt from the ISPE iSpeak blog from June 2020. It's called Agile Software Development in GXP Regulated Environments Special Interest Group. And I quote, "There is a very broad spread of levels of adoption of Agile, especially in the end user pharmaceutical companies, but also with suppliers who often perform their base product development using Agile, but then feel they need to provide something to the pharmaceutical company that looks like it was waterfall. In the worst cases, perfectly sound Agile software development activities are performed with the necessary deliverables, and often these are within tool sets rather than documents, which are then reverse engineered to produce a suite of traditional documents. This is wasteful and potentially very confusing, as then two sets of deliverables need to be maintained or aligned through the system lifecycle. It also raises the risk of a compliance failure should there be a difference between the two that is subsequently discovered during an audit. It raises the question of where the source of truth lies. So as I mentioned earlier, we've leveraged the Agile development tool Jira with a number of plugins to handle our lifecycle tasks and support traceability to the user requirements. And here's just a quick illustration as to how compliant Agile development could look like. You have your user requirements, which get mapped to what are called user stories. Each of these user stories is assigned a risk category based on how it might affect how the end product supports product quality or data integrity. The user stories get converted by the developers into system functions and design elements. So as the user story gets implemented, test scripts are developed by an individual who is not directly linked to the implementation. Is to ensure that there is no conflict of interest, developers do not write the tests for their own code. When the user story is complete and ready for testing, tests are executed by another individual not associated with the development. And a third-party QA person oversees these activities, and if all tests pass, marks the user story as complete. If the test doesn't pass, an investigation is performed, which could lead to a new user story for tracking any non-conformances. Okay, so now I want to chat a little bit about cybersecurity and cyber resilience, which are a major concern in all industries, but specifically in the pharmaceutical industry. The end user, or regulated company, is still responsible for their GXP data, whether it lives on-premise or in the cloud. So you need to protect your sensitive data throughout its lifecycle to preserve data integrity. There are some risks to having regulated data living in the cloud. Security and hence compliance becomes a shared responsibility with your cloud service provider. You are not directly in control of the reliability, availability, and performance of the cloud-hosted environment. So, how do we address those risks? Well, first off, we built the application on a secure platform, the Ignition system from Inductive Automation. Ignition is proven to be a trusted environment for handling GXP applications over the years and has gained the trust of the industry. We implemented DevOps processes, such as separating out the development environment from the test and production environments to protect the live system from uncontrolled changes. And as per 21 CFR Part 11 for open systems, our system encrypts data that gets sent out along the public internet into the cloud. And we performed our own supplier assessment of our PaaS provider to ensure that the proper controls are in place for the protection of sensitive and GXP data. Vendor management is one of Grantek's key tenets and is at the heart of our QMS, especially as it pertains to cloud applications. So I just wanted to highlight a few key elements of our vendor management program. We begin by identifying the level of risk that the vendor poses to the quality of our applications, which defines the level of assessment required, similar to how it's done in the ISPE GAMP guide. We have processes in place to manage our vendors throughout the life cycle of our relationship with them, from selection through qualification, maintenance, development, and then to discontinuation. Okay, so now we're going to take a peek at CloudEMS itself. So just what does CloudEMS do? Well, the simple answer is that it does what an EMS is supposed to do. It pulls sensors at a pre-configured frequency and triggers condition-based alarms for those sensors or devices based on configurable limits. It notifies the appropriate users when alarms are triggered, either through email or SMS text. It produces multiple reports, alarm reports, trends, and configuration reports. It is a configurable solution. It allows administrative users control over the alarm configurations, user and group configurations, and notification configuration. And it has a web-based user interface. It allows for alarm acknowledgement with the ability for users to add notes. It has a main dashboard for quick access to the status and current value of the sensors. It has a flexible trending interface and a filterable alarm list. You can see currently active or historical alarms and drill down into the alarm details. And it has an audit trail, so QA could see who did what and when. So here's a look at the application hierarchy, how it's divided. You have three main areas: the environmental monitoring area, the reporting area, and the configuration manager area. You navigate throughout the application on the left-hand side and click on the icons to switch between the main areas. In the environmental monitoring area, you have the main overview, also called the dashboard or home. From here, you have a tree of monitoring locations, which is modeled according to ISA 95. So you can have your sensors split out across the enterprise, site, building, area, etc. Off to the right is the rooms overview, which displays an image of the selected monitoring area and the sensors or metrics on the bottom. The status, name, value, and units are all shown. Status could be none if the sensor has no configured alarms, good, or one of many alarm levels. Alarm levels range from diagnostic all the way to critical. The metrics are searchable, sortable, and printable. Pressing the icon at the top that looks like a trend line will switch from the room's overview to the trend view, which we'll walk through next. The trend view can be either real-time or historical. You can select which values you want to view and the range, either the last X hours or days or weeks, etc., or a date time range for a historical trend. There are a number of controls available to enhance the visualization. You can pan and zoom, and then revert back to the original trend. You could do an X trace to see the values in numerical form where the trend lines cross the cursor. You can add a range brush so that you could focus in on a specific area of the trend. You can switch to a full screen view, and there are other features as well. You can also print the trend and export the data from the system. Pressing on the icon that looks like a grid will bring you back to the overview. Within the environmental monitoring area, beneath the overview in the navigation pane is the alarm screen, which shows a filterable, sortable list of the current alarms, color-coded by priority and status. It's from here that you'd acknowledge alarms and enter notes. Pushing on the alarm clock icon switches to the alarm history view, which displays all events pertaining to historical alarms. Events include when the alarm was triggered, when it was acknowledged, and when it was cleared. This list is also filterable and sortable. Pushing on the bell icon switches back to the active alarm view. And now we get into the configuration area of the application. Here we are in the Alarm Manager. It's from here where a user with the appropriate permissions can add and configure alarms. The alarms are associated to individual metrics, following the same tree structure that is in the overview screen. Alarms can be assigned to either analog or digital metrics. The system allows for flexible alarming configurations. You can alarm when a value is equal to a set point, not equal, above or below, between two set points, outside of two set points, and more. All changes are logged in the audit trail. And here we are in the User Manager and the Role Permission Manager screens. It's here where application functionality is assigned to roles, as well as where the individual users are created, modified, and assigned to a role. The system can use a company's Active Directory for retrieving user accounts, or the accounts can be configured locally if no Active Directory is present. Each user can be assigned to a schedule configured in the Schedule Manager, which we'll get to later on. And this is the Notification Manager screen. From this screen, you would configure which users get notified when alarms get triggered and how they get notified. To help streamline the number of notification configurations needed, the system allows you to create alarm groups so that you can configure the same notifications for a single alarm or multiple alarms. Notifications can be sent through email or SMS at this time. You can configure the system to send notifications to individual users or to groups of users created in the Roster Manager, which we'll get to next. And here is that Roster Manager. It's here where you would create user groups or rosters and select which users go in those rosters. This feature makes it easier for selecting multiple people to receive alarm notifications. And now we have the Schedule Manager. This screen allows you to create schedules so you can filter out when users can receive notifications. You can create a schedule for individual days, the work week, or all days of the week. You can also create shifts and notification windows for various users so that they only get notified when they're working or on call. There is also a repetition feature that allows for rotating weeks or days on and off. For example, you can configure alternating day and night shifts for a specific user. Finally, we get to the reporting area of the application. Note that all user actions that affect the logged data or notifications are audit trailed. In this section of the application, a variety of reports have been created. You have a report that displays all events that pertain to the alarms. You have an alarm configuration report, a user configuration report, notification configuration report, and there are other reports as well. All reports are downloadable as PDF files. Okay, so now we get to peek under the hood and take a look at the technical architecture of the application. Here's a simple image that shows multiple sites of a single customer. In each site, there are 3 air handlers, and they are all communicating with a single edge device. The edge device is running an edge-enabled version of Ignition, which allows for store and forward and encryption functionality. The edge nodes send their data up into the cloud to the PharmaStack platform, which is where the CloudEMS application and data storage lives. Users access the application via web clients. The application can access the customer's Active Directory to retrieve user account information. Okay, so now I'll hand things over to James to talk in more detail about the PharmaStack platform.
Yeah, thanks, Bryon. So what I'd like to do is explain a little bit more about what is PharmaStack and the technology platform that Bryon has mentioned a couple of times in the previous slides, and give you guys a little bit of a peek into to what it is. So PharmaStack is a fully managed hybrid cloud platform designed for use in GXP environments. It provides an easy and secure method for developing, deploying, and maintaining Ignition applications in those environments. And there's several important features and components that are included as a part of the platform. So first, it's an isolated environment for each one of our subscribers. It has automated backups and 7 years of data retention. We include a pre-built starter kit, which includes some best practices for Ignition, for data integrity, and for electronic signatures. Built into the platform is source control using Git, including application changes and evidence generation that can be used for change control activities. We have optional DevOps deployments. So Bryon had mentioned several environments for the CloudEMS application. That's available for standard subscribers as well. You can have as many or as few environments for quality, for development, for staging, for integration servers, for production servers as you need for the application that you choose to use. And then, as a part of what we do as the platform as a service is we provide all of the operating system, application updates, service packs, and those are all tested and verified and according to our quality procedures deployed into what's called the container repository, and then that's made available for deployment into the application environment of every one of our customers. What's kind of neat about it is it's a totally scalable deployment. So the same code base fundamental architecture stays the same, whether you're doing a small proof of concept for a single point, or if you're doing this across multiple facilities or big enterprise level scale. And included with our services are 24/7 support. We have automated systems and tripwires included in the system that will monitor and send us proactive notifications should there be any kind of issues with any one of the subscribers. And then we have some options that we're not really going to talk about today, but we're capable of doing some hyper-converged architectures, deploying within customers' tenants, and adding in custom software to meet the operational needs of what a particular customer is looking for from the platform. So what does it mean? What this means is that for CloudEMS, we're handling the underpinnings, we're handling the security, and we're making it such that Grantek and the product development team at Grantek can focus on the functions and the features available as a part of CloudEMS. Next slide, please. So Bryon, a couple of slides ago, mentioned something about store and forward. That may not be a terminology that's familiar to everyone, but certainly it's a super important part of this architecture, and I'd like to go into a little bit more about how data actually flows through the system. And this is true for both the CloudEMS as well as a standard PharmaStack installation. But really, I'll just start off by describing kind of the architecture at a detailed level here. So if you see on the diagram in the left, we show a factory. There's an internet connection in between, and then there's a PharmaStack instance just to the right of that, living in the cloud. So the edge device in this scenario is able to talk with hardwired sensors, existing controllers, existing databases, PLCs. It's really capable of a lot of different communication methods and different protocols. So what happens is the data is received by the edge device, and then it's timestamped as it arrives at the edge device. The edge device then forwards the data through an end-to-end encrypted connection that's wrapped inside of a VPN to the PharmaStack instance in the cloud. So the data is fully encrypted in transit and at rest. During normal operation, this flow is consistent and the data arrives and is stored in our time series optimized cloud database in real time, close to real time. If there's some issue with the internet connection, which we know happens from time to time, the edge device will store the information that's being collected, including the arrival timestamps, and wait for that internet connection to resume. The system is capable of handling up to 1 week of information in its data queue. Once the connection is revived, the edge device will forward all of the missing data to the database, including the correct timestamps that were marked on arrival. The edge device we're using in this architecture is called a Groove Epic, and it's made by a company called Opto22. The name EPIC stands for Edge Programmable Industrial Controller, and it allows for a single device to act as a PLC, a communications interface, a data buffer, as well as a failover node. So you can also see on the right-hand side of this diagram that we have a connection to a data lake. So if there's a desire to ingest the data that we've captured into another system for analytics or the application of AI, it's very easy to do that once the data is put into a cloud database. We expose an API, and that information can then be consumed by whatever analytics platform or whatever data lake that is being used by a customer or by an analytics company. So with that, I think I'll hand it back to you, Bryon.
All right, thanks, James. Okay, so now let's talk a little bit about the current roadmap we have for the CloudEMS product. So yes, we do have a roadmap in place for CloudEMS. And the first thing I wanted to note was at the moment, it's available in the Microsoft Azure ecosystem, but we are working toward it being available in AWS in 2023. But for the application itself, our initial focus is going to be on the addition of some mobile-first functions. Primarily, we're looking at adding push notifications. In addition, we have some user interface or UI, UX enhancements planned based on some initial customer feedback that we received. In addition, we've seen interest for similar functionality outside of the pharma life sciences space. So we're planning on having a non-GMP or a other industry flavored version of the CloudEMS application hosted on another flavor of 4IR's platform, the FactoryStack platform. Further down the road, again, based on interest from existing and potential customers, we are planning to add SCADA-like functionality with local fallback capabilities to offer a BAS system hosted in the cloud or a hybrid cloud on-premise solution. Looking further and wider, We see CloudEMS as our first cloud application and plan on adding further cloud-based applications tied to other use cases, both within and outside of the pharma industry. Okay, so that brings us to the end of our presentation. So thank you all very much for watching. As a call to action, if you have an interest in either CloudEMS or either of the 4IR platform as a service offerings, please feel free to reach out to myself, Joe Waters, or Ben Payton from Grantek, or directly to James from 4IR Solutions. James, any last words from you before we get into the Q&A?
No, I think this is really a great use case for the platform, and I appreciate the opportunity to be a part of the presentation. Thank you.
Great. Okay, well, thanks everybody again for listening. So I'm just opening it up for questions. See one come in right now. I guess it was one from the point of registration around, it says, how secure is your remote monitoring and what type of protection technologies or processes do you use? And I think, James answered that question when we looked at the kind of detailed architecture of the PharmaStack platform around the, the use of encryption and the use of, encrypting that data and having it residing in a VPN so that it's encrypted both in transit and at rest.
Yeah, I can probably add a bit to that too, Bryon, is that so the way the system was designed was taking, for this first version in Azure, it was taking the best practices for deployment from Microsoft, as well as the best practices from inductive automation, and using both of those blended together to create this platform as a service. So there was several decisions made around architecture and around configuration that were based on kind of the melding of those two worlds, including things like application gateways and VPN services, as well as how the system is configured. For those more kind of technical on the call here, we are using a containerized version, which does reduce surface area for attack as well. So certainly happy to describe in more detail, but yeah, that was kind of one of the core design tenets of FactoryStack and PharmaStack, was to ensure that we've taken the best practices from a security perspective from both the application providers as well as the cloud providers to provide.
Great, thanks, James. We have another question that came in about does the application support multi-factor authentication? And the quick short answer is yes, it does. James, I don't know if you could walk through a little bit more around the technical side of the multi-factor authentication piece.
Yeah, it's actually so each one of the tenants inside of PharmaStack gets its own Azure AD instance, and then basically the Azure AD instance can then have guests added to it from your Office 365 or your Azure AD for your end customers. So we can enforce things like multi-factor authentication as a part of that. And what's cool too is if you have someone who leaves the organization because we're authenticating against your identity provider, that's handled out of the box. So it essentially removes their permission when you remove their permission. There's some more advanced permissions as well that can be done in addition to that as a part of the application set, probably a little deeper than we want to go today in the conversation, but yes, it includes multi-factor and integrated authentication with your identity provider.
Great. Thanks, James. Man, there's a lot of questions that are coming in specifically for you, James. We have another one.
You got to talk through the whole presentation, so I get to at least contribute something else.
Yeah, we have another one around can this work with something else other than like a different platform besides Ignition, basically?
Yeah, so the basis of PharmaStack was built around Ignition because Ignition was the first major SCADA platform or major SCADA software that was available with containerized deployment. So it's a key part of our architecture that allows for us to be able to, I mentioned earlier, the ability to scale, the ability to manage, at scale. That's enabled by some of these cloud-friendly technologies like containerization. We've had conversations with a whole bunch of different manufacturers of software in the space. There's roadmaps for most of them to start offering their software in this manner. Not many are there yet, but that's part of what we see as a maturity step in the building of automation software and SCADA software specifically. So that's the long answer. The short answer is we can do different software. We can make things work in all sorts of different ways. It's really a question of the suitability for how we manage things. So we're happy to have a conversation if there's something specific that you're interested in operating from the cloud.
Okay. The next question is around the specification for the Opto22 edge devices.
Yep. So the model number is the Groove Epic PR2. By default, we provide the controller and a backplane, and then if there's additional modules that you'd like to add for sensors, I/O, etc., then that's totally up to you to add. The Groove Epic PR2 is the faster of the two models that they sell, and is, I see another question here about can it communicate with other devices, and yes, that's part of what you gain with some of the capabilities of that platform.
Okay. Another question is around the speed to market capabilities for new construction. And yeah, I think that's part of one of the benefits of this being a cloud-based application is that, it actually enables a quicker speed to market. You don't have to wait until until your big server room or your data centers are built. You could actually have the solution designed and ready to go, and basically you'd really all be doing your temperature mapping, installing sensors, getting the edge device deployed and hooked up to your the internet directly, and then you have the application is ready and waiting. So there is a enabler there for speed to market.
Yeah, and from the edge device that we have specified in this is an industrial device. It looks like a PLC. It's rated to 70C. Sits on a DIN rail. So from an installation perspective, it can be included in a control panel.
Yeah, and that was actually kind of leads into another question here around integration with existing controls, and can my controls architecture expand with CloudEMS? And yeah, so because we're using this particular edge device, you can connect sensors directly to the edge device, or you can have the device communicate to PLCs out on the plant floor to retrieve environmental data. I mean, this particular application, the CloudEMS application, was built specifically as an environmental monitoring system. So if you're looking to use it for functionalities such as monitoring OEM equipment, that's not specifically what it was designed to do. However, Grantek does plan on actually, we have another product actually in the works under development right now for being an OEM data repository in the cloud. So that's a great question.
Yeah, and maybe, and I think maybe the question I'm going to ask the person who wrote the question: are you talking about more expansion to other areas? Or are you talking more about, hey, I have an install base of BAS systems or environmental monitoring systems now, control panels, et cetera? Can I go talk to those instead of installing new sensors? Is that more what the question was? Yes, can it talk to
Mhm.
existing? So yes, that's part of the capabilities that the edge device helps provide for us, is the ability to communicate with existing systems over a variety of different protocols, to be able to collect information from different sources, be they directly wired into it or over drivers. So yeah, that's one of the cool benefits of it, is its flexibility.
Got a few more questions here. One of them is around whether the platform supports communication protocols besides MQTT, which it does. It also supports through the edge node, supports OPC UA, and I believe that it also supports other protocols as well. James, if you would get help out with a little bit more of the technical details there.
Yeah, you can use the gateway network as well through Ignition, because the edge device is actually running an Ignition node or Ignition edge, depending on the application. MQTT is a great option as well, and then there's lots of different things it supports. But out of the box, MQTT and the gateway network are kind of the two primary edge to cloud sort of communication protocols. Both TLS encrypted, both really robust, different features for each. And then, certainly when it comes to scale, if you're looking at scaling out to a much larger volume, we've done some architectures for customers with redundancy and with additional brokers in the cloud, if you are planning to use a big distributed MQTT system. So yeah, there's lots of really great options around that. From a protocols on the floor, basically it's everything Ignition has. So Modbus, DMP3, serial, you can do all kinds of stuff. OPC UA.
Okay, so and a lot of these questions, there was an earlier question around what do you see as being some of the key differentiators of this particular product as compared to other packages or other similar packages. And I think, yeah, that's one of the what you had just said, James, around the flexibility of the platform to communicate with a variety of devices across a variety of protocols is one of those key differentiators. I think another key differentiator is the compliance piece that we've gone and done some of that work to help with respect to the qualification of the platform, to prove that we've implemented this under a state of control, and hopefully reduce the qualification burden for end customers, which again leads to some of that speed to market piece, where you already have a pre-qualified application core. Really, you would really be responsible for qualifying the method of deployment of the application on site and its configurations. I mean, there's
I think it's also worth mentioning that the application is all built in HTML5, which is called the Perspective module in Ignition. So, mobile device friendly, visually much more appealing than SCADA screens used to be. So,
yeah, so there's a number of key differentiators as well. I mean, not application specific, but the Grantek has a very robust service and support program for our customers, and this product benefits from that. And I saw some questions come in around temperature mapping, sensor procurement, calibration. Those are all things that Grantek's team provides, all services that they provide, that can be blanketed bundled together with the CloudEMS platform to give you a robust turnkey solution that with support built in and all that good stuff. As well, there was a question here around yes, when you deploy any new computerized system, there is a lot of internal work required. Training of the users, creating SOPs, doing that formal validation and qualification activities. And the question was, are you prepared to assist with any of this? And yes, the answer is Grantek does have both internal resources as well as the compliance consultant that we partnered with for the CloudEMS application to support our end users with through a lot of these internal activities, that not just buying a piece of software, but getting it ready to go and to be used in the manufacturing space. Then we have, is this another question here around, is this limited to environmental phenomena, and does it handle digital signals or only analog signals? So the EMS, like this is an EMS, it is not specifically limited to environmental phenomena in that it does actually handle digital signals. So it could do things like monitoring door open, door closed. If you wanted to monitor, your clean room doors, it could monitor if you had a value coming back from a particle counter that you wanted to pull in, it could grab that as well. But the CloudEMS application is specifically designed, to be an environmental monitoring solution. As I said, we do have plans underway for expanding into other use cases. One of them that I mentioned was the being able to retrieve and store data from a variety of OEM equipment. But yeah, this application is specifically an EMS application. And actually, that's funny because the next question was, could the 4IR PharmaStack platform be used to gather information from OEM equipment and historize it? So James, maybe I'll let you elaborate on that. I think I've given my 2 cents around that, but
yeah, actually that's a pretty common use scenario for PharmaStack / Factory Stack. Both we didn't really talk much about Factory Stack. It's the non GXP version of PharmaStack. And has been released for quite a bit longer, and that's actually a pretty common use case that we've seen is for either monitoring OEM equipment or for doing exposing of data from a system that is isolated. So hey, I have this performance management system or this piece of equipment that I want to be able to visualize, view the status of, and get some reporting or do some analytics on. The concept of having Ignition in the cloud as a modeling tool, and as something that you can use to collaborate and pull data in from a bunch of different sources, and then do both functions using that application, but then also have that data model be available for other applications to use, is a little bit different way to think about ingesting data into the cloud, but certainly is something that we folks that have kind of gone through that realization process, we think have been very excited about it because it solves 2 problems for them. It solves the visibility, monitoring, management, control of all of these assets from a central location, but it also solves the how do I get this information contextualized, put into an appropriate format, ready for use in other systems. That's just kind of built in as a part of the way it works when you connect the system like this up to the top. So yeah, I think I answered the question.
Yeah, I think so. And I think just getting a warning from our team that we're approaching the end of our time. So we have one last question. It's so there's a company, I guess, with an enterprise-wide data lake in AWS. So how would you architect this system to pipe the data into it? I think you gave a bit of a hint to that in the architecture, James. I don't know if you had wanted to elaborate a little bit.
Yeah, it's actually real simple. Basically, once the data is in the managed service in the cloud we use for data storage, we simply expose an API for read-only access to pull the information out. What's nice about it, again, I mentioned in the last answer to the last question, is that part of us creating this, or whoever is creating this application, is to collect all this data, organize it, contextualize it, and create all of the information that you would need to use it. So then once you want to go and start pulling it into other analytics or other more different data sources to connect things together, from production to labor and supply chain information, it's ready to go. So for us, it's as simple as exposing an API and having a tunnel in to pull the information out.
Great, thanks, James. And thank you everybody for attending the webinar. Just as a reminder, all the registered attendees will be sent a recording of this webinar. And if you had any other questions, you could reach out to either James, myself, or the other gentleman from Grantek that I mentioned earlier, or you can just email your questions directly to info@grantek.com.
And there were a few questions we didn't get to answer on the list. We will make sure to answer those as well.
Great. All right. Thank you, James, and thank you, everybody. Have a great rest of your day.
See you guys.